In the xy plane, if a point with coordinates AB lies in the solution set of the system of equations above, what is the maximum possible value of B? Okay, so this is a system of equations. It tells us that outrightly, so we don't have to guess what concept this is. And we are told that there's a maximum point, AB, that we can find from this system over here. So the question specifically wants to know what the maximum y value is. So remember, the B really is the y value that we are looking for here. Now, because we have many methods for solving systems of equations, it appears as though this one would be best solved using the substitution method. Why? Because you have, y's are isolated already. And this symbol says less than or equal to, emphasis on or equal to, because that allows us to say y is less than or equal y. In other words, this y is definitely less than or equal that. With that said, we can set up the equation as follows. 5x is less than or equal negative 15x plus 3,000. We're basically setting those two inequalities equal to each other. And now we have just a two-step equation. So to solve for x, why don't we start off by adding 15 to both sides, like so. The result of this will be 20x is less than or equal 3,000. And of course you are solving for x, so you got to divide each side by 20, and you're going to end up with x is less than or equal 150. Now remember, this question was not asking you for the a value. A is the x value. We don't want the x value. We are looking for the y value. So we have to take this 150 and plug it back into one of these two equations to find the y value. That's what we're after. Well, of course, we want to do the easier thing. So we would use this equation rather than the top one. So we would have y must be less than or equal 5 times 150. This being the section 4, you are allowed to use a calculator. So 5 times 150 is 750. That means the y value can be less than or equal 750, meaning the maximum value it can be is 750. So that's it. Answer to number 36 is 750.